We have already seen that there are various kind of images in the image data. So like face images, object, various type of object images, scan images, like X-ray images. Is various kind of, we have seen the various, there are various kind of image data. Image data, if you think is, so it's various kind of image data they are available. Face image, it may be a object image, it may be a scan image, scan X, scan, various type of scans, MRI or something like that. X-ray image, X-ray image. But in just previous video, you have seen by simply using the deep learning concept, we can detect the what should be the best features for time series data like image, video, like this kind of thing. But there have another technique in features engineering that they call the histogram technique. In these histograms, in histograms, by simply using this technique, we can also detect some beautiful features on this image data. So let's see these things step by step. So there are two types of histogram technique in image data. So in one is color histogram and another one is age histogram. One is color and another one is age histogram. Okay. So let's try to understand what is this color histogram. Then I'm going to then is a discount. Let's try to understand it one by one. What is color histogram? What is color histogram? Let's understand it. And how this technique, color histogram technique, helps us to find some beautiful features of the images. Let let's suppose this is our images. This is some images we have. Now, first thing that you have to do, suppose let's use the M cross N pixel image. It's an M cross N pixel images. It's in this here we have M cross N. This suppose let's say here we have M number of rows, N number of columns. Yeah, suppose let these are and the small portions of it is called the pixels of pixels. If you are a computer students guy, then you have already computer science students guy, then you have already known these are the pixels. Each portions are called the pixels. And each pixels is the combinations of three colors. Each pixels are combinations of three colors: red, green, blue. RGB, red, green, blue. And the H color, red, green, blue, are its density are will lie on the 0 to H value on that H cell will lie on the. There are various techniques, but in the simplest one, it is 0 to 255. On this range, the H cell value which lies is like okay. So now based on this value, we have defined how what will be the density of the each color, what will be the density of the red, what will be the density of the green, what will be the density of the blue based on this value. 0 means the most lowest density and 255 means the highest density of each. Okay, that's the color actually itself. This one on 0 to 0 to 255. This range is also 0 to 255 and as well this range is also. So that's the thing. So the first step in the color histogram, first technique that we have to do in first stage, we have to do, we have to find the red values for each pixels. For each pixel, there are three colors: red, green, blue. First thing we have to do the for red color. Okay? For red colors, For red values, for red values, for corresponding for each pixel, corresponding for each pixel, first we have to find the number of data points, means how much data points they have, how much pixels they have, m cross n pixels they have for each pixels. So we have to find the number of data points. So how much data points? M cross n. We have here in m cross n data points, m cross n data points, and based on this m cross n data points, we have to build the histogram. On this m cross n data points, we have to build the histogram. We have to build the histogram. So the here histogram structure will be look like this type. Yeah, let's see it carefully. Here the so each pixel, just see it, each pixel's value is b. First I have taken the only red color for each pixels, but each pixel's value contain three colors: red, green, and blue. For red color, its density, the density of the red color, green color, blue color are like on 0 to 225, 0 to 255. So this value will be, this range will be start from 0 1 to like up to 255. This lowest density value, this is the highest density value. Okay, now we have to find the, here it will be the number of frequency of red colors, how much on this range, it will be the frequency. Okay, suppose let's, we have got some picture like this, we have got some pictures like this. Like this type of, like this. Okay, suppose like this, just see it from these pictures, you can conclude that in these regions means about these regions, about these regions, its value is, its frequency is mostly high. And suppose let's its value is suppose somewhere 100, somewhere 150, 150, somewhere here its value. So it's around 150's range, around the range of the 150, somewhere here to here. So around the range of the 150, mostly red color occurs. So most its frequency is high. So most of the red colors occurs in this densities regions. Here I have some little bit regions. Okay. Then we can conclude these things from here. So just by simple using this, so we have to now convert this histogram technique into a vector format. Let's see how we'll convert this thing. This is the histograms. Now we have to convert this histogram into a vector format. So vector format will be look like now. So how much value we have? 0 to 255. So this value will be 0 to 250. First value is 0, 1, 2, 3, 4. Look like this. 255. Okay. So 0 means, just see it. They are have on the 0 range, they are have some frequency. 1 range, they are have some frequency. Means age here, they have some frequency. Somewhere here 150. Somewhere here like that 150 it will have. Somewhere here. So just see it. The on this 150, it's get the most value. It's get the maximum value. Maximum value it gets. So from this technique, from this red color, from this red color, we can, all this red color frequency is that this red color is This is the features vector of this red color frequency. This is called the features vector. Or red color. Okay. Now same things can done for the green color and the blue color also. Uh, just see it. X pixels combinations of the red, green, blue, and by using this density, we can plot the histogram, and we can convert these edge histograms into a corresponding features vector. Okay, now the same things we have to apply onto the green color and blue color also. The same technique we will apply for green and blue color also. I think you like that. Now let's see. Using the simple features vector of edge colors, how we detect something. Suppose let our task is that there have some tasks we have. Let our task is we have to interest to find some there have some sky or not in some picture. Suppose task is have to find sky or not in a picture. In a picture. There have some sky have or not. That's the task actually that we are interested to do. Okay. Now how we'll do that? So just see it. Suppose let this is our picture. So if there have some area on the sky, suppose let's if there have some area on that sky, on the sky, that means what? In that area, the density of the blue color is most high. So let's write it. If there have sky, that means what? That means the density of the blue color on that particular area is high. That implies the density of blue color is high. Okay. That means that, and we have the features vector of each color. Since we have the features vector of the red color, something something. This is the features vector of red color. Look like this type of. We have features vector of the blue green color with features vector of blue color. We have already counted, and itself for the edge features vector gives us the how much density it has, how much density it has. Okay, these are the actually just see it. If these features vectors are gives us the what will be the density values. Just see the from this picture. This is a frequency. So how much density is there have. So and we have know the maximum density value is 255. From the edge cell, we can conclude that how much maximum value of the frequency they are have. So if we got from these three features vector, if we got that there have most of the area occur the maximum density values of the blue color, then we can conclude that there have the sky. So first, that thing that we have to convert this features vector. Now we have to convert it into a vector. This vector will be like this. This is the for xi, and suppose let this is for yi. This is the xi and this is for yi. In this xi, we have three features vector for red, green, blue. These features, this vector will be responsible for red. This features vector is responsible for green. This features vector is responsible for blue. And this is the x vectors and this is the y vector. By simple applying, if there have some sky means the blue portions will be high, blue value will be high value, then we can conclude that if yes, if they are have the some high. So intuitively we have doing these jobs for using color histogram. Using this color histogram, we will use these things by simple to find some object they are have now. This is one features, not actually it is the most important feature. This is one the very simplest features technique that we maximum times we have used it. Okay, so that the color histogram, that we have that seen that only it gives us some intuitions behind some, there have some object of not based on the color concept. Okay, suppose let we have to detect some there have some face, some size, some shapes there have or not. Suppose let we have interest to find there have some human faces or not, or there have some face means triangle, square, like that kind of shapes we have interest to find on that image there happen. So these things are not given by the color histogram. So if you find them some recognizing some shapes, if you interest to recognizing some shape, the color histogram, for example, it is impossible to give. The color histogram that not give the answer. Color histogram don't give this answer. Do not give this answer if they have some shape. So to find the shapes, we have to use the concept of the aged histogram. Let's see how these age histograms are actually working. Let's see it step by step. So age histogram. Let's see it. How these things are actually work to find the some shapes, beautiful shapes on the image you have or not. Suppose let this is the our some picture. There have some shapes. First thing that we have to do, we have to partition our paste. Suppose let there have some picture like that. There have some pictures like this type of pictures there. Okay, there have some this kind of pictures. We have to find its shapes. So first thing that you have to do, you have to partition each image into a small pixels, into a small pixel. Suppose let's it's one pixel, 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 like that. Here one pixels, here one pixels, here one pixels. Like we have to find the edge pixels. Based on these pixels, we have to find its what will be just see this shape on these pixels, on this pixel. If you look like closely, then this picture will approximately look like this type of shapes. They have this type of shapes. This type of means what is the angle? This shapes. So this is the 135 degree. If you just take this shape, suppose let this shape, if you take this picture, then the shape is straight and this shape angle is 90 degree. If you take this picture like that, like this type of means I'm talking about this, suppose like this shape. So look like this type of straight line if you take. So this shape means how much angle should be means this type, like 135 to little bit small 110, like that means. I think you got the point how these things are. There have no here. You take these shapes, it's look like straight line, this type of 0 degree look like this type shape. So first thing we have to partition its pixels. How we have to take its small pixels. On these pixels we have to find the edges and what is the angle of the edges. That's the thing that we have to first to do. So for edge recognitions, for edge regions means I'm talking about for edge pixel. It's false pixel. For edge regions, first thing that we have to do, first thing to based on the edge value or edge angle, we have to plot the histogram. For edge regions, first thing based on the edge value or edge angle. Based on this edge value or edge angle, we have to plot the histogram on it. We have to plot the histogram. Okay, first thing that we have to do. Now, suppose let the histogram that we plot here look like this type. Look like this type of histogram we plot here means here how much values we have. It may be possibles 0 to 180 degree, or suppose let's say stay minus 1 to 180. Its value is possible. So we have to find the histogram means frequency here. Suppose let's the pictures is look like this type. This type of picture we got somehow. We got this type of picture. That means what? The maximum angles are on this in. Suppose let's take this angle is somewhere. Let's take somehow this angle is mm, one about 90. Okay, let 90. Somehow let sometimes let it. So this is a histogram of the corresponding edge pixels, and based on this histogram is based on the edged value or edged angle value. This histogram, and just see it on these examples. We've taken that maximum edge are on 90 degree means 90 degree means I'm talking about it's the vertical line, vertical edge. Okay. Now if you convert this, after that we have to convert this edge into a vector. We have to convert edged histogram into a vector. To convert it, most simplest one as previously we have seen already this thing. Look like this. Here it will be from -1 0, look like up to 180 degree. So each cell now contain the frequency value of it. Each cell it now contains the frequency of it. Okay, here each cell with the frequency of the east angle. I'm talking about edged angle. Okay, these things are edged. It will be the frequency of it. Okay, so this is the simple features vector onto it. So suppose we know if you some there have some faces. Suppose from some concept, basic concept we know if there have some faces look like this type of. If there have some faces, then it is the face. If there have some faces, then its features vector will be look like this type of features vector there may have. 180 degree. So if there have some faces, so let's it's in these angles their value will be high. On this angle their value will be high. On these angles their value will be high. On these angles their value will be high. If they have just using this simple concept, phase concept on this, they are this kind of angles they are have. If they are have, then we have to compare these things to this vector. Now we have to compare these things to this vector. We have to compare it. If this distance are the closed, most unapproached, then we can conclude that yes, they have some phases. If it is not, then we have not sure about it. We have to process for the further step. So this is the actually one kind of technique find the shape to find the sizes, find the various kind of shapes they have on our image or not. It's the one kind of technique. It's the most not one. It's the simplest one. Okay. It is the simplest one. So and also they have various technique. In next video we have see the shift technique. That's a very good technique for recognitions the object. Okay, and also in deep learning chapter we have seen the CNN combinational neural network chapter. We have seen it how much actually deeply they have. So the color histogram. So the color histogram and the AST histogram. The technique that we have seen, it's the very basic and fundamental technique. It's a very basic and fundamental technique to find there have some shapes or node of there have some color based on the color combination. So if we find some objective on our image, that's that they are the helps us to find it. Okay. And I think from these discussions you will got the idea how this histogram technique helps us to build some beautiful features vector data sets. Okay. So in next video we'll see the shift technique. How the shift techniques helps us to detect the features, to detect the various type of shapes of an image. We'll see it next.